Hi, this is Lee again, and I'm going to show you another subsystem on the TRILLSAT prototype that I've been working on. And this one is a haptic system called Tethered Haptics using Morse pulses, or thump. And what it is it uses the tether itself as a communication medium, and at the base, this would normally be the ground, a thump or a pluck or hammer at the base will cause a wave pulse to go up the tether. It'll reach the craft's accelerometer in the center, and then the craft can respond back by vibrating this 1 pound eccentric mass. And because of where it's located, it will create transverse waves along the same axis that will come down the tether. Now it can also orient it differently and send longitudinal waves. Now I'm going to come over here and show you how I'm decoding this. Okay, originally I created about a couple of years ago a decoder. This is for a game, and it decodes standard Morse code, and you see the dit and the da and the da and the dit dit dit. But for this system I had to invert the algorithm to decode the pauses between the elements, or the pauses between the pulses, to use the pauses to encode the information. And the reason for that is, and I'll come over here again, when an acceleration pulse is made in the tether, that would signify a dit, but creating a pulse 3 times longer in duration to signify a da would be impossible in this setup. I mean, it's too constrained to create such an acceleration pulse. So I'm going to come back over here and show you what happens. So, for example, an A would be dit da, but in this Syntheo SHH algorithm, which stands for Syntheo sh, as in sh, quiet, for example, it would be a dit dit followed by a long pause of about 3 or about 4 das, and then a final element or final pulse. This pulse changes the last element to a da. The reason for that is when you invert the Morse algorithm, it doesn't know whether or not that last element is a dit or da, because it pauses to time out and it doesn't know how long that pause should be. And so that final pulse is necessary if it ends in a da. Now, in A to Z, they are all up to 4 elements long. So if there's a 5th element, let's say one that ends in da, like J, notice that you don't have to wait that long pause before entering that final element, because the 5th element automatically signifies the end, and it signifies a da. So there's a couple of different ways to do it. Now at the bottom, there are 4 sequences of 4 elements that are not International Morse code at all. And I just named them F1 through F4. And notice that 2 are kind of similar, da 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 and da 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 dit. And when you enter them in using this other algorithm, they're very similar. So I use these 2 F1 and F2 sequences to signify a command that was entered correctly, like a control code. And the reason I use 2 of them is due to their similarity, and you can easily enter them in similar ways, and because I could attach another binary meaning to F1 or F2 if I needed to. So I'm going to back up here. And oh, by the way, this is a phone running an XMPP client. And the XMPP system is the normal system that I would use to control TRILLSAT. I'm trying to focus it here. There it goes. And there's a secondary system, a packet radio system, that I can use. And then there's a third system, which is an SSH console using the Pi Wi-Fi system. But this 4th system, this haptic system, can be used when those systems go down or the client goes down. For example, I'm going to come back over here again. This client, for example, if it loses battery power, it can only be charged if there's no electrical power available through the craft. And the craft would be up in the air, and there's a wireless QI dock here that allows it to receive a charge. and that gets it through its batteries, which ultimately get it through solar power. So it's completely independently powered, both client and server. But if I cannot enter a command to lower the craft or turn on the QI charger, then it's kind of useless. So this system allows me to go over here and enter a command, and then it could like lower or turn on the QI charger or do any function. So I'm going to go back over to this client, and I'm going to turn this on macro mode here. Okay, so I've created an EEPROM haptic passcode that I can set on the microcontrollers. I'm going to type in an XMPP command called code, capital E, and this will set it ahead of time. Okay, and the Pi over I2C is sending, it sent the code to Huckleberry and Sawyer, the two AT Tinies, and what they're doing is they're setting in the EEPROM that code, capital E, and the capital letter sequences, the two capital letter sequences, there are 676 combinations, so I can set a type of passcode. So that code is now set. Now if I go over here and try tapping on the side of the craft, you see the LED spotlight lit up, and then it blinked back a response. It received a DIT command. Now I could type all kinds of pulses on the tether at this point, and it will not unlock itself to allow commands to be entered unless that capital E is received. Now I set it to capital E, because an E is just a DIT, and that's easy to unlock for this example. So what I'm going to do now is I'm going to turn on the haptic mode, because right now I have it in a test mode. So if I set pulse mode to 1, instructions are being sent to Sawyer and Huckleberry, and they're just sent to set their echo and replay modes, because what's happening is they're operating in parallel, and they have to kind of coordinate together to receive and then send back the haptic response. So right now, what should be happening is, instead of echoing it to the light like it did before, it's going to keep the light off, and it's going to send it to, no, it's actually going to echo it, sorry, but it's not going to replay that DIT, and that sends the information to Sawyer, and then Sawyer is going to perform the replay on the motor. So I'm going to go ahead and hit the case again. Okay, that was the information. Up. I've got the motor voltage turned off. I'm going to turn on series mode. I've just boosted the voltage of the batteries so the motor will activate. I just had that turned off. Okay, so I'm going to go ahead and tap it. Okay, the motor has just sent back a response. I'm going to hold it here. So now we've got haptic input, haptic output. So now I'm going to go ahead and I'm going to do that EE combination to unlock the passcode. So I'm going to go down here and I'm going to type a DIT. Okay, here we go. I'm going to send a DIT. I have the threshold set too high. I'm going to go ahead and lower the threshold. I'm going to lower the threshold to 5. THS, it's a command I've got to change the accelerometer threshold setting. Okay, it's 5. It's more sensitive now, just for testing purposes. Okay, here we go. But still, I'm going to hit it harder. DIT. Should send back a DIT. I'm going to send one more. DIT. DIT. All right. At this point, the craft is unlocked. Now I can send that Q command. I'm going to show you here. That is actually what you hear now. That's Oswald, my automation robot. Anyway, da da dit, da. So I'm going to go ahead and do that. Okay, now I've got it lined up on the dock, on the QI dock. I'm using rubber bands, but I could also use Velcro straps. Now I'm going to go over here and enter in that cue. It's a da, da, dit, da. Da, da, dit, da, and a final da. Okay, that's correct. Now I'm going to send F1, da, da, da. I'm just going to keep doing das until it registers. Well, I don't know if you see that, but the QI charger just kicked on. For some reason, the phone did not make a noise. I thought it would make a noise, but if you see here, it is now charging. That turns on the QI charger. I could turn it off by taking the phone off and issuing a command to turn it off, but I'm not going to do that yet. Okay, let me show you something else. The craft, when the roll is horizontal, a wave pulse detection is like you would expect. It's registered on the x-axis by the accelerometer. But if the craft is tilted to the side, acceleration due to gravity has an effect on the pulse detection. So I've created a command, an XMPP command, that allows me to experiment with this called ref. And I typed in ref, and it sets the register on the LAS 3DH accelerometer to cancel out any acceleration. So right now it's as you would expect. I could tap it on the side, and there you saw the light flash. It detected the pulse and it sent back the response. But if I were to tilt the craft heavily to the side, I'm going to do that here. Oh, I'm setting it off here. Okay, I'm going to let it stabilize. Okay, I think, let me try tapping on it again. Alright, it did not light up. It is less sensitive to detecting an x-axis pulse. I'm hitting it pretty hard. Now I'm going to go ahead and let it stabilize, and I'm going to set the ref variable. Or register. Okay, I just set ref for that angle. I'm going to hit it again. Okay, that time the light came on. So, the reference has to be correctly set for every angle. This is an unusual case for this type of craft because it does tilt to track the sun. A normal hoist bot or cable bot might stay level and not need that.